Welcome back to Joe Smart Tools, where math is made easy. In this session, we are comparing fractions with unlike denominators using our LCD method. And if you're ready to see how to compare fractions, let's get started. So in our example today, we are comparing fractions with unlike denominators, and in this session, we will be using the lowest common denominator method. Now, the lowest common denominator method is similar to finding the LCM or your lowest common multiple. So for this method, I'm looking at the numbers in my denominator, which is 7 and 6, and I'm looking to find a number in their timetable that is common to both 7 and 6. Now with 7 and 6, to find the LCD, it's just like listing your multiples. So I will do that just to give you a clearer idea as to how we find the LCD. So what I'm going to start with is by listing the first 7 multiples of my 7 timetable, which is 7, 14, 21, 28, 35, 42, and 49. I will now do the exact same thing with 6, which will be 6, 12, 18, 24, 30, 36, and 42. We can usually start with the first 7 or first 6 and then identify where there is a common number in both of their listings. Now, for persons who do know their timetable, they will not have to go through this process because you probably would have already been able to identify a multiple of 7 and 6 that they have in common. But for my persons who are not there yet, this is how we usually find our LCD and our LCM for 2 or more numbers. So for 7 and 6, a multiple that both of these numbers have in common, we can see in 7, there's 42, and in 6, we also have a 42. So that means now that for both of my fractions, the LCD that I'm going to be using for them will be 42. Now with finding the LCD, this is only step 1. In our last series, we did equivalent fractions where we learned how to convert fractions into their equivalent fraction form. So for this one, we're given 42 in our denominator. And we know that when we multiply 7 times 6, and if you're not sure what number you are multiplying by, just go back and count your timetables up to the number, or just count the numbers up to the number that you have circled. And I can see that at 6, I was given 42, so that means that 7 times 6 is equal to 42. So I will also multiply 3 times 6, which will give me 18. And now I'm going to do the exact same thing for my next fraction. So in my 6 timetable, I see that at 7, I was given 42. So that means that 6 times 7 is equal to 42, and 2 times 7 is equal to 14. So that, and comparing my fractions now that their denominators are the same, I see that with 3/7, their equivalent fraction has 18 in the numerator, which tells me that 3/7 is larger than my 2/6. Okay, so let's move on to a second example. Okay, so now we have a second fraction that we're going to work through with converting first to our equivalent fraction and then comparing. So now we're looking at the numbers in this denominator, and in our denominator for this question, we have the numbers 8 and we have 16. Now, there are going to be occasions where you may be working through questions where you're given numbers that you have to find the LCD for that are a bit on the larger side. And with the calculation up to the 7 timetable, it may be a little bit difficult or it could be a bit tricky, especially if you're someone that struggles in your timetable. So here's what we're going to do. I'm going to start off by going step by step. And what I usually do when I have larger numbers, I usually encourage my students to probably write out the first three if you can and see if there's a common factor, or sorry, a common multiple within the first three numbers. Because in some cases, you may find a common multiple for some of your numbers within the first three multiples. And then if at that point you don't, then you'll have to go to another three if possible. So let's start off with the first three multiples for our numbers, and then if need be, we will go a little bit further. So for A, I will have 8, 16, and 24. Now for 16, my first multiple is 16. When 16 is multiplied by 2, we will get 32. And when 16 is multiplied by 3, we will get 48. Now, in listing the first three, the good thing is we identified a common multiple between both 8 and 16 with our number 16. So 16 is going to be the common denominator that we are going to be using for both of these fractions. So now that we have our denominator, let's now begin converting our fractions to their equivalent form. So for 8, we have 8 times 2, which equals to 16. And for 5, we have 5 times 2, which equals to 10. And then for 10 16, we already have 16 in the denominator, which tells me that 16 was multiplied to 1 to get 16. So 10 times 1 will also equal to 10. So because both of our equivalent fractions are the same, or the equivalent form of our fractions are the same, that tells me that 5/8 and 10/16 are equivalent fractions. And remember that equivalent fractions are two fractions that are equal to the same amount or same value, but they're just written as different numbers. So with 5/8 and 10/16, they are equivalent fractions of each other. So that means that these two fractions are equal. Okay, so there you have it. We just compared two fractions unlike denominators. As always, get some additional practice in, and I'll see you right here in the next video on Joe's Math Tools, where we aim to make math easy.